This is the second recording in Unit 1, and in this recording we will be going over how to write a good experiment and some of the branches and careers involved in chemistry. When you are out in the world and doing science and designing experiments to test hypotheses, it's always good to keep some fundamentals in mind about how to design your experiment so that you can answer the questions that you have. And any good experiment should have some different parts. A good experiment should have the following: controls, constants, independent variables, and dependent variables. And so typically a good experiment will have all these different components, and we will talk about each individual component and then try to kind of put it all together at the end. And I have a little saying that helps me remember the parts of a good experiment. I go CCID, like yes, I can determine the question at hand. And in this, I'm going to use an example experiment that I'm going to write about peanut butter. And so I'm going to pretend like I am a peanut butter manufacturer, and I want to make a new type of peanut butter that will compete and sell on the grocery store shelves. And so I would need a control to test my experimental peanut butters against. And a control is a standard of comparison. And so let's say I have three different experimental types of peanut butter that I want to evaluate, or a new brand of peanut butter I want to develop. And I'm taste testing those, and I just give them to individuals out in the public. Well, they taste them and they're all fairly positive about the peanut butters and rate them pretty good for taste. But I really don't know unless I include a control, one that I know that sells well, that's popular, that people like the taste of it. I really don't know if I have something here or not that will compete. So you have to have a standard of comparison, and whenever you think of the word control, think of standard of comparison. This is the benchmark to compare all the things tested in your experiment. It's also a way to ensure that multiple trials of your experiment are conducted in the same way. So if I were to go out into the public and do a taste test at a mall or a grocery store or an elementary school, for example, I'd want to have the same control in there, and that helps me to keep a more uniform experiment that is set in a way that doesn't vary a whole lot. Example is taste testing. This new peanut butter, you could use Jif or Peter Pan in your trials, and you would also, always need to have that as one of your samples so that you can determine if you have a good experiment or not. Let's say that you feed this to people and you do a taste test, and all the data that you get is negative, even with the Jif. Well, if you get negative data from an individual or individuals, you can assume that they don't like peanut butter, because everybody that likes peanut butter tends to like Jif peanut butter. Constants. Okay, so constants are things that remain the same during the experiment. This is very important. The only thing that you want to change in your experiment is the thing that you're testing. So in our case, the only thing that we're going to change is the varieties or the experimental types of peanut butter that we're feeding individuals. So if we are doing a taste test, we don't want to have Coke as an option for a drink with some people and milk as an option for some people, because that might affect their taste tests. And so when we give the peanut butter out, we'll want to have the same beverage given out to everybody. Either Coke, I guess you could probably get away with Coke and Pepsi as some sort of soft drink, or milk or water, but you can't mix and match those. The drink has to stay the same. Maybe the time of the day that you give the taste test needs to be the same. You wouldn't want to give some people an opportunity to rate your peanut butter before lunch, for example, and some after lunch, because that might affect their opinion of the different varieties of peanut butter as well. But that doesn't mean that you can't go back and do another experiment where you just test the peanut butter after lunch or before lunch and see if that makes a difference or not. They should be kept the same and across the trial so as not to skew the results. For example, our peanut butter trial, you want to keep the constant the type of beverage. We already talked about that, to wash the peanut butter down. Independent variable. The independent variable is a variable in the experiment. It is the subject of your test. That is the thing that you're testing. In this case, it's different types of peanut butter. But let's say that you are interested in, feeding a particular type of food to dogs, for example, to see how it affects their coat. Maybe you're a person that shows, let's say you like to show Shelties, Shelton sheepdogs, and you are interested in finding the best food to make their coat nice and shiny. Well, the variable that you are testing is the type of food, and the dependent variable is the amount of shine on the coats. And so the independent variable is what's being tested in your experiment. Example here is the peanut butter, and in particular the taste of the peanut butter. We said that that is a qualitative type of trait, how the quality of the peanut butter, but we might want to put a quantitative evaluation of that trait. We might say that 1 is not a very good tasting peanut butter and 5 is the best. And that measurement that we have is the dependent variable. The dependent variable is the variable that we use to evaluate the independent variable. It's a thing to be measured. It's a yardstick for that independent variable. So in this case, it is the peanut butter. What's the best peanut butter? And here we have some volunteers that are tasting our different peanut butter to evaluate it for taste. So our rating scale, we're putting a quantitative trait to a quantitative evaluation to a qualitative trait. We're going to give it a number so that we can do some statistical analysis later. So the dependent variable is the one to be tested. And it's very important that you try to kind of hold on to these principles when you're designing your experiments, and that you don't mix and match things too much. You just keep everything the same except that one thing that you're testing. And that way you can test your hypothesis better. So again, you have a control, a standard of comparison. You have constants, things that stay the same throughout the experiment. You have an independent variable. That's the subject of your experiment, what you're trying to find out about. And then the dependent variable is your yardstick, how you're measuring the difference in between your independent variables. This part of our discussion, we talk a little bit more about chemistry and branches of chemistry as a preview for the course. Chemistry study of matter and the changes it undergoes. We've already kind of covered that, but we didn't say that we were particularly interested in energy exchanges. And that is a branch of chemistry that is super important, not only in biological systems, how well that they adapt and how well that they change, but also in our world. And we'll talk more about that as we go along. Inorganic chemistry. Webster defines it as a branch of chemistry concerned with substances that contain little or no carbon. I always find that a little tough to get my hands around. I hate having a definition that tells you what it's not about, but really the organic chemistry has long chain carbon molecules, and it involves things like polymers and plastics, and we'll talk a little bit more about that later. And so inorganic chemistry has to do with like chemistry of compounds that are involve more elements and aren't really these polymers and plastics, and then to a certain extent biochemical compounds as well have long carbon chains. So we're talking about everything that's not these big synthetic compounds and long carbon chain molecules like polymers and plastics, and also long carbon chain biochemicals like proteins and enzymes and carbohydrates and fats and all those types of things. So that's the major focus of this class, but we'll also introduce some of the other ones as well. This particular compound that we're featuring here is titanium dioxide, and it is in almost all paints. It is what really makes paint paint. And then what you do is you put different things into the paint to give it color, to maybe make it rust preventative, maybe good to stick to metals, maybe water-based. So, but almost all paints have this titanium dioxide in it. This is the focus of our class, like I said, but we'll also introduce some other things as well. Physical chemistry. Sometimes in school we call this P-Chem. And it is the dreaded subject for a lot of chemistry majors in college. It is the umbrella of chemistry that contains thermodynamics and kinetics. And thermodynamics is energy changes, in particular heat changes in materials. So this is a very math-intensive type of chemistry, and it's also super important. We have some fireworks here, and certainly when you shoot off fireworks, you get brilliant blaze, light energy, and if you get too close, you get heat energy as well. And so thermodynamics is just that, heat changes. And kinetics is the studies of how molecules move to make up this exchange of energy, how particles move, their movement through space and time. And it is a super interesting branch of chemistry as well. Organic chemistry. Organic chemistry is the study of long carbon chain molecules, once thought to just be from living sources. And really, the interesting part about this is when you go out into the public and talk about things that are organic. Well, they'll say, the mushrooms that I get at the farmer's market are organic mushrooms. And what that means is they're grown without any pesticides or herbicides or that kind of thing, that they're totally natural and they don't have any man-made substances in contact with them. But in chemistry, organic compounds also involve some not natural things like polymers and plastics. And we are highlighting a very neat jacket. Let me see if I can pick up my pen here. Okay, here we go. A neat nylon jacket. And one of the first organic compounds that was sold commercially was nylon. And I believe DuPont Chemical Company was the one that came up with nylon. And nylon started off as one that was used primarily for women's hosiery. And in the wars, they were very scarce. The women's hosiery were scarce in World War II because they found that they could use nylon to make rope and that sort of thing. And now they make jackets and all sorts of synthetic materials out of nylon. They're very, very, very useful. And polymers and plastics in general dominate the manufacturing process. And a lot of times people in chemistry will say that you go to school and study more inorganic chemistry, and then when you go out into the world you practice organic chemistry, and you're involved more in polymer and plastic production and that sort of thing. Another example other than nylon is polyester in clothing. Biochemistry. Biochemistry is one of the foundations for studying medical type of applications of chemistry. So as you can well tell, bio being, of living things, and so biochemistry is the chemistry of living things. And so if you are going to go to veterinary school or medical school or pharmacy school, you would certainly study a lot of biochemistry and have to have a sound foundation in that to further your studies. Examples of some biochemicals involve proteins, fats, lipids, and many, many more. And certainly a fascinating aspect of chemistry. I had a course in biochemistry in college. I really loved it. It was really intense, and I had to learn a whole lot about biological systems, and how they work, how the chemicals in the biological systems work together to make healthy plants and animals. And it's a really cool aspect of biology and of chemistry. So this kind of concludes our introductory unit. I hope you have enjoyed it. Then in the next unit, we'll be studying matter and measurement. And we'll get into some of the statistical analysis involved in evaluating experiments. We'll also talk about how that you make good measurements and how you record your data. And then we'll talk about all the things matter and how we classify matter and how we group matter into different categories and start really laying the foundation of our nuts and bolts chemistry discussions. So cool. Really enjoyed this, and I hope you did also.